This video is going to be about a chemical reaction on redox, oxidation reduction. And what I have here is silver. Doesn't look very shiny, not very silver-like. And that's because silver has an affinity to sulfur. And sulfur is found in our atmosphere. I'm guessing it's due to the pollutants that we have. Anyhow, the silver is bonded with the sulfur that's in the air, and it's given it this oxidized purplish, bluish, blackish color. We call it tarnish. Some people may call it patina. But actually, any silver that has been protected from the atmosphere, the elements, will look a little bit better, like the lid. Look how pretty and shiny that is. That's what this is supposed to look like. But it's been oxidized. So I want to be able to get this in a reverse reaction. And how am I going to do it? I need to find something other than silver that is more attracted to sulfur. And I found it. What I found was aluminum. Aluminum has more of an affinity for sulfur than silver. It's a stronger bond to sulfur. So I looked at this and I'm thinking, how come my aluminum foil that's been in my kitchen for some time, how come it's not tarnished? If it is more, it has more affinity for sulfur than silver, why doesn't it look more black? So when I researched foil, I found out that it has an oxide coating on it. So for this reaction to take place, I have to remove the oxide coating. How am I going to do that? In comes sodium bicarbonate. And the sodium bicarbonate is going to remove the oxide to allow access to the atoms on the aluminum so that the reaction can take place. Here's something else I found. Regular table salt. So the regular table salt, and I don't think I need very much of this, maybe a teaspoon or so, a tablespoon. It's to help the electrons flow through the solution. So it's transferring from the silver to the aluminum. And how are we going to get this to move? What solution are we using? Water. And of course, the hotter, the better the reaction. So give me a minute and I will get your hot water ready. Okay, so I have here a clear glass with some aluminum foil in it. And I'm going to put in some salt. Doesn't have to be very much. And again, that salt is to help the electrons move more freely in the solution. Next I have is the sodium bicarbonate. This is not very much. It's just enough to get the reaction going, to loosen up the oxide coating that's on the aluminum, to make those aluminum ions more available, so that way the sulfur from the silver can transfer to the aluminum. So now I'm going to get the hot water. And this is really hot. You'll see the steam coming off. And what you noticed was a hydrogen gas, but it was only for a minute. And you can see how quickly the change is occurring. Oops. Can you see that? You see how quickly that is changing? Look at the top of that silver lid, how tarnished it is. But the part that is in the water, touching the aluminum, the sulfur is already moving. It is transferring over. So this reaction only took seconds for it to happen. And take a look at that compared to the sugar bowl. Remember, and you can even see it on the top of that lid. I was going to leave out the sugar bowl, leaving it aside untouched, so that way it would be sort of a control to compare how this chemical reaction was going to take place, how much of it really did react. And as you can see, it really did take the sulfur off. It transferred onto the aluminum. Now obviously, the longer you keep it in there, the more it will take off. But it's only taking the sulfur off, not the silver. So here I'm going to try with the creamer. You can see how badly tarnished it is. Now when we did the sugar bowl lid, it took seconds for that reaction to take place. It's only been 30 seconds. Let's take a look. Look at that. So as you can see, some of it that was touching didn't quite get all the sulfur off. But if I put it back in there, let's see how much longer it takes for it to fall off. Oh my goodness, you can also see where I just dipped it in the water. That only took seconds. And again, this part wasn't touching the aluminum. It just needed to be in the water where the electrons are flowing through the solution, removing from the silver to the more attracted aluminum. So this was a chemical experiment of redox reaction, oxidation reduction, taking silver sulfide plus aluminum with the reactants of sodium bicarbonate and hot water to react to loosen up the sulfur on the silver to transfer onto the aluminum. So now we end up with the product of silver and aluminum sulfide.